الرحمن الرحيم. شلونكم طلابنا؟ إن شاء الله عطلة سعيدة ولو هي قليلة، بس هذا وش نسوي، ظرفنا الراهن. موضوعنا اليوم على ال Analytical Epidemiology. Definition of basic terms. أول شيء, first of all, the risk is a probability that an individual will become ill or die within a specified period of time or age. It is used to denote incidence rate. So this is important to know what is the meaning of risk. Risk is a probability of something happen, whether disease, whether death, or an event in a certain time period. And this will indicate incidence rate of any of these, as we said, disease or events or whatever. So what are the risk factors? They include, first of all, risk marker, which is an attribute or exposure that is associated with increased incidence of disease or other specific outcome. For example, if the patient have heart attack, like myocardial injury, and followed by necrosis and inflammation, and followed by healing, then the scar formation, as here in this photograph. So what will happen? There is a tissue marker. We call the troponin marker of MI, myocardial infarction diagnosis. Earlier, the doctors depend first of all on the sign and symptoms of MI for diagnosis, and later on they depend on ECG changes. Lastly, the troponin enzyme marker is the earliest and the most important indicator of MI. So this is a risk marker. And other risk marker is coronary arteries thickness, detected by the MRI, magnetic resonance imaging. And this is an important marker for also myocardial injuries. And we have another third marker like tumor markers, especially in those with family history of malignancy. These tumor markers are early finding, suggest possibility of malignancy later on. Number 2 or B, here we have the determinant, which is attribute or an adjective or exposure to certain things that increase risk of disease or specific outcome. Like here, for instance, a patient with autism, usually there is unknown etiology, but also there are prenatal factors and environmental factors or exposures that are claimed to cause autism in certain people. Prenatally, like maternal infection of rubella or maternal exposure to certain medications like thalidomide, valproic acid, or here the environmental exposure like heavy metals, poisoning, lead, mercury, arsenic, and others. The prenatal factors and environmental factors are maybe we can prevent their occurrence by any intervention. So these are modifiable risk factors. But here the genetic factors, like here in single gene disorder, in bone error of metabolism, and genetic variants, and there are risk alleles. These are genetic factors, they are non-modifiable. So these are the determinants, they are risk factors. Maybe we can interfere and prevent their occurrence, or they are non-modifiable, like here in genetic factors. C, or number 3, the modifiable risk factor, as we said, modified by intervention therapy and reducing the risk of disease. Here we have a non-modifiable and modifiable. Non-modifiable, like the age, we can do nothing for the age, and gender, genetic factors, race, ethnicity, and family history of certain disease, we mean there is genetic factors. Or modifiable risk factor like hypertension, smoking, diabetes, physical inactivity, obesity, and high blood cholesterol level. We may interfere to modify the effect of this risk factor. So what do you mean by relative risk? Relative risk is a measure of strength of association between an exposure and outcome. For example, the exposure to daily environmental factor, to damp weather, to air pollution might cause asthma, attacks of asthma. So is there any association between the exposure to environmental factor and the attacks of asthma or appearance of asthma? The result value here is an indicator of the significance of exposure in the etiology of the outcome. So it means relative risk, the association between the etiology and the outcome, the environmental factor and asthma, high blood cholesterol level and cardiac lesions or attacks. So the relative risk is calculated by here incidence rate among exposed on the incidence rate among non-exposed. So the value of relative risk factors depend on the difference in the incidence rate of the disease in the two groups, exposed and the non-exposed. As here we have two groups. As we said, exposed, they are the cases, and not exposed are the control. The greater the value of relative risk is, the stronger the association, and more likely that association is causal. So if there is high risk factor, this risk factor is the cause for the disease or the outcome. We have here cases. These are a group of patients. They are exposed to swimming in a kiddie pool. Here, the incidence of giardiasis in this patient is equals to 12.9%. And here another group, they did not swim in a kiddie pool. So the incidence is less, of giardiasis is less. But the relative risk, how we calculate it? By division of the incidence in those swimming in the pool over the incidence of those not swimming in the pool. And the number or the result is indicate how many times it is greater, the incidence is higher if they have the risk factor of swimming in a pool over those not swimming in the pool. So it is a 3.3. So it is 3 times 0.3 greater in people who swam in the pool compared to those who did not. Again, relative risk, or we call it the risk ratio. It is the incidence of outcome with exposure over the incidence of outcome without exposure. So interpretation here, if the relative risk is more than 1, so there is increased risk of outcome. While if it is equal to 1, there is no risk of outcome, and if it is less than 1, there is reduced risk of outcome. So relative risk ratio is a ratio of two probabilities. Either it is a cause or there is no causal relation. What do you mean by attributable risk? It refers to the fraction of the incidence rate of the disease that can be attributed to the exposure to the risk factor, or by other means, it means how many times factor exposure would increase the incidence rate of a group. How many times this factor exposure increased the risk of incidence rate in the group. Calculated by a formula, attributable risk is equals to incidence risk among exposed minus the incidence rate among non-exposed. Suppose we have a population of 8,000 people divided in two groups, smokers and non-smokers, and each group checked for a heart disease. The outcome may be affected or not affected. So here we have 8,000, as we said, in the population, smoker and non-smoker. 3,000 were smokers and 5,000 non-smokers. And those who develop cardiac problems among those smokers, here only 84 from the total 3,000. And those who develop cardiac diseases among non-smokers was 87 out of 5,000. So we have to calculate the incidence rate for those who develop cardiac diseases and they are smokers. It was here 28 per 1,000. And the incidence rate among non-smokers who develop cardiac diseases, it was 17.4. So the attributable risk is, as we said, it is the difference between the cardiac diseases among incidence rate of cardiac disease among the smoker minus the incidence of cardiac diseases among non-smokers, and it was 10.6 per 1,000. This is the attributable risk. What's the significance of the attributable risk? It gives an idea about expected gain in health and life, or the expected reduction in incidence rate if the risk factor is eliminated. If we remove that risk factor, which is here, it is smoking. If we equip from smoking, the expected reduction in the incidence rate if they give up smoking can be expressed as percentage out of the incidence rate among the exposed as follow. Percentage reduction. We have two formulae, or either it is incidence rate among exposed minus incidence rate among non-exposed over the incidence rate among exposed multiplied by 100, or it is percentage, as we said, attributable risk over the incidence risk of the exposed group multiplying by 100. And this is another table to show you the meaning of relative risk and attributable risk. As we said, we have the factors, exposed and non-exposed, and we have the incidence, whether yes or not, and we have the total number here. So we have to see what's the difference. So what do you mean by association? Association is a statistical quantitative dependence between two or more variables, like smokers and cardiac lesions, smokers and non-smokers. So variables are said to be associated if they tend to occur together more frequently than could be explained by chance alone. So the degree of association is determined by statistical test, example odds ratio, which means probability ratio. And types of statistical association, either it is causal or non-causal. Causal, which means either direct, which means here smoking lead to hypertension, or indirect, as smoking leading to hypertension, and this leads to cardiac problems, cardiac attacks. So direct or indirect. This is if it is causal. There is a causal relationship. If there is non-causal or no causal relationship, when the apparent association due to confounding process, that is a third factor, is related both to the risk factor, to the cause, and to the outcome or the effect, or we mean the disease. So the odd ratio is a statistical that quantifies the strength of the association between two events, A and B. The ratio of odds of B in the presence of A and the odd of B in the absence of A. Here we give example for confounding association. Two groups in a population were studied for cardiac insult, and they are coffee drinkers and non-drinkers as a control. Coffee drinkers are the cases and non-drinkers are the control group. Positive association found. That means the incidence rate was higher in the drinkers than the non-drinkers, above 1. But at the same time, both were smokers as well as in different percentage. The sharing factor, that is smoking, founded accidentally, may attribute it to the congestive or cardiac heart disease or chronic heart disease development rather than drinking coffee per se. So this is the third factor, which is attribute to both the cause and to the outcome, and it is not included in our study, but it's found accidentally. This is what we call confounding association. This will make association determination difficult. And a statistical association likely to be causal if the following criteria are fulfilled. 9 epidemiological criteria done by Austin Bradford Hall. First of all, the strength association. The larger the association, the more likely it is causal. And dose-dependent relationship. Greater exposure should generally lead to a greater incidence of the effect. For example, greater exposure to radiation means there is a high possibility of malignancy, especially in skin malignancy, dermatological malignancy. But in other cases, low exposure might end with disease, like low exposure to sunshine, they lead to rickets. but mostly greater exposure is a cause for a greater incidence of the effect. Third, the time sequence. Temporality. The effect has to occur after a cause and not the cause after the effect, not in reverse direction. The cause and then followed by the effect. And fourth, experimental evidence, removal of exposure alter the frequency of the outcome. If we remove the radiation, the frequency of malignancy is less. Consistency, consistent finding observed by different persons in different places and different samples. And we have specificity, there is one-to-one relationship between the exposure and outcome. There is no other relationship, only single relationship. Not that this is uncommon in reality. And coherence, the relationship found agrees with the current knowledge of the natural history, biology of the disease, and laboratory finding that increases likelihood of an effect. So it is some sort of logic. And the relationship found agree with the logic, with the natural history, with the natural biology of the disease, and even with lab investigation that increase the likelihood of an effect. Biological possibility, there is a potential biological mechanism that explains the association. And analogy, the relationship is in line with other established cause-effect relationship. For example, knowing of the teratogenic effect of thalidomide may accept a cause-effect relationship for a similar agent based on slighter evidence. And here, to know something about the analog, boys is to girls as man to women. We have other biological criteria we called the Koch postulate. Koch postulate, again, we have to fulfill this criteria. Agent is regularly found in a lesion, like here. This is a healthy organism and this is a disease organism. Always we can detect the organism in the lesion and the diseased one, and here detected by microscope and isolated in pure culture in an artificial media. And it will cause, if we inject to a healthy agent, a healthy organism, this agent might cause disease again, and lastly agent is recovered again from the diseased animal. This is a biological criteria, Koch's postulate. So we will discuss analytical study. Observational analytical study, the research attempt to explore how and why a disease process is maintained in a given population or place. Why? Why happened diabetes more in southern or in the eastern country, or in maybe we have malaria in north of Iraq? Why it occur there and how? We always use control groups and we test hypotheses. Whether it is accepted or not, it will depend on the evidence, on adequate evidence to support it. If the evidence is inadequate, so the hypotheses are not accepted and further study may require. For example, it might be suggested that parental smoking increases risk of acute respiratory infection among children aged under 5 years. To test this hypothesis, we have two groups and we have two types of analytic epidemiological study, including case control, and we have cohort study. In case control study, the definition is study that compares patients who have a disease or outcome of interest, they are the cases, with a patient who do not have the disease or outcome, they are controls. We look back retrospectively to compare how frequently the exposure to the risk factor is present in each group to determine the relationship between the risk factor and the disease. Here, this is the case control study. We start here from the disease group of interest. Maybe they are cancer patient or pneumonic patient or asthmatic patient, and here the comparison group, they are the control, they are non-patient. So we take the history from both, and we have to see, after taking a history, compare histories about the exposure to certain things that facilitate the appearance of disease. Maybe in cases of cancer here, they exposed to radiation or certain medications or certain disease that aggravate cancer developments, and here they have no such history. And then we have to draw the conclusion. In case control study, the exposure and the outcome or disease have occurred before start of the study. So we collect a diseased patient who have certain disease, and we have to take other group. They are control, they are free from the disease. The study proceed backward from outcome to cause, from the disease to the cause of that disease, and the control used to support or refute any inference. Two groups of persons are studied. The first consists of cases and the second are the control, and both cases and control are preferably matched for the age and sex, and sometimes they are matched for other variables, but overmatching is to be avoided. So the basic steps are selection of cases and control, matching for confounding variables, at least the age and sex, and measurement of the post-exposure in both groups, and then analysis and interpretation. To illustrate a study design, we have to identify number of children who are suffering from probably pneumonia. Suppose the number is 240, and we have equal or more number of children matched for age and sex, but they are free from pneumonia. They are control. And suppose they are 380 patients, and we have to compare between them. So the measure of association in case control study will depend on the old study. What do you mean by old study? Old study mean the exposure and the disease here. We have 2 by 2 table. Exposure, if it is present or not, and the disease is present or not. Odd ratio is a ratio between those exposed and have the disease and those they don't have the disease. Thank you.